All right, this set of notes is going to be on solving for x with variables on both sides. So the title of the notes are just going to say variables on both sides. Today's date is the 20th. Okay. So there are two things to remember when solving for x in an equation with variables, which in this case would be x, on both sides of the equal sign. That says sign. Here are the things that we need to consider. Number one, we want to move all the x's to one side of the equal sign. And we do that by using inverse operations. Okay. The other thing that we need to consider is that we want to move the term with your variable that is smaller and when I say term, we're looking at the coefficient of your variable. And I'm putting x in parentheses because we typically are looking at the variable x, but sometimes your variable can be other letters as well. So we're going to do two examples, and then that will be it for our notes. So example number one. For example number one, we have 3x plus 9 equals 10x minus 5. Okay, so we want to draw our equal wall and we are solving for x, but this time we have variables on both sides of our equations. So first thing we want to consider is we want to move all the x's to one side of our equal sign. Currently they're on 2, and we're going to do that by using inverse operations. The second thing is we want to move the term with our variable that is smaller. We're looking at the coefficient of our variable. So if I look at these two terms that have x in them, I have 3x and 10x. So I want to move the term that is smaller. Out of these two terms, 3x is going to be smaller. So I'm going to use inverse operations to move that 3x to the other side of my equation. So if this is a positive 3x, the inverse of a positive 3x would be subtraction of 3x. And again, whatever I do to one side of my equation, I have to do to the other. That 3x cancels out, and I'm left with 9 equals 10x minus 3x will give me 7x. And then I'm going to drop down that minus 5. All right, now we're just solving for x. So this is just like a two-step equation from our past notes. So if I'm using my inverse operations, the first thing I want to do is get rid of this constant at the end. And I'm going to do that by adding 5 on both sides. I'm getting rid of this constant first because, remember, if we think about SADMEP, right? We have to do addition before we do division. So I'm left with 14 equals 7x. Okay, and I got 14 because 9 plus 5 is 14. Now I'm going to divide both sides by 7, right? To get rid of this multiplication of 7, I'm going to divide by 7. I get x all by itself, and 14 divided by 7 gives me 2. So that is my first example. Example number 2. Okay, example number 2, we have 7 minus 3x equals 2, parentheses, x minus 4. So before we can even start moving x's, we need to simplify this side of my equation, the right-hand side. What do we need to do? First, we need to, starts with a D, distribute. So I need to distribute that 2 to both parts inside of my parentheses. 2 times x gives me 2x. 2 times negative 4 gives me negative 8. I haven't done anything to this side of my equation yet, so I'm just going to drop it down. All right, now we have an equation with x's on both sides of my equation. So I want to move all my x's, all my variables to one side of the equation using inverse operations. And I want to move the term or the variable that is smaller, looking at the coefficients. So here on the left, I have a negative 3x, right? Because that minus makes this term negative. And then I have a positive 2x. Which is smaller, negative 3 or 2? You got it. A negative 3x is smaller. And so in order to move all my x's to one side, I'm going to move the smaller one. And to do that, I'm going to add 3x on both sides. Those x's cancel out. And I'm left with 7 equals 2x plus 3x is 5x minus 8. Drop down that minus 8. All right, now again, we're at a two-step equation like our notes previously, and we are trying to solve for x. So using SADMEP, I'm going to add 8 to both sides before I divide. So I'm going to add 8 here. 8 plus 7 gives me 15 equals 5x. And then my last and final step, I'm going to divide both sides by 5 because this represents multiplication. To undo multiplication, we're going to divide. 15 divided by 5 is 3 equals x. And that's it.